Hello there. In this video we're going to be looking at 3D trigonometry, and the first topic we're going to look at is how you can find the lengths of lines in a 3D shape. Let's start with the simplest. Let's say, given this diagram here, you're asked to find the length of the line AC. Well, it's just an application of Pythagoras. Excuse me. If you look, CB must be the same as DA, and then we're trying to find this length here, AC, so we use Pythagoras. And Pythagoras says that x is equal to the square root of 9 squared plus 7 squared equal to the square root of 81 plus 49. And I'm going to leave it in third form because I don't lose any accuracy that way. So it's equal to the square root of 130. So this length here, x, is the square root of 130. But let's say the question then has a second part to it. They do this a lot in the exam. They have an introductory part that's fairly straightforward. And now they ask you to find the length of AG. Now, how do we find that? Well, we've already found this length here. We know the length GC. That's going to be 4 centimeters. So we use Pythagoras again. So this length here, I'll call that y. The length AG, which I've called y, it's equal to the square root of root 130 all squared plus 4 squared. Now, that's why I left it in third form. The square root of 130 all squared is going to be 130 plus 4 squared, which is 16. So the answer is, in third form, square root of 146. There's an even quicker method. If you're trying to find one of these lines that crosses diagonal lines in a cuboid, basically you could do this. If you look at it, it's going to involve 9 and 7 and 4. So you could have done it quickly as the square root of 9 squared plus 7 squared plus 4 squared, which equals 81 plus 49 plus 16. In other words, the square root of 146. Now let's look at another application of 3D trig, a harder one here. What we're going to do is, we've got this a pyramid, square-based pyramid, and we're going to try and find the angle that the line EC makes with the plane ABCD. Now, the angle it makes, we define it as being this angle here. The angle that the shadow makes onto the plane with EC. So it's going to be this angle here. So it's x degrees that we're trying to find. Now, how can we find it? Well, I need to know this length here, this length in blue. Now, how do we find it? Well, there's quite a bit to this. I've got to find this length. Oh, hang on. If I call the point directly underneath EX, I've got to find the length CX. Well, how do we find it? Well, I know this length here. How can I find that length there? This looks like this teacher's buying time. Well, let's have a look. Let's work out the length AC. Obviously I didn't prepare it, and halve it. Now, AC equals the square root of 12 squared plus 12 squared. In other words, it's 2 lots of 144, so it's 288. So that is 288. So x, or CX, is equal to half of that. Now that I know that, let's use our trigonometry. Just remind you again, SOHCAHTOA. I mean, if you're looking at 3D trig, then you're obviously quite an able mathematician and you know this one by heart. But let's have a look what the problem involves. Here's my angle X. I know the side opposite, and I know the side adjacent, that half 288. So I'm going to be using the tan ratio. So the tan of x equals opposite, which is 5, over a half of root 288. So x is equal to tan to the minus 1 of 5 over a half times 2 root 288. Let's get the calculator to do all that. So here we go. So shift tan to the minus 1. So I'm trying to work out the angle. The main part of this calculation is a fraction. So it's 5 over a half times the square root of 288. Now use the replay button to make sure we get the bracket closed, and voila, it's 30.5 degrees. Okay, there we go, to one decimal place. So remember, to find the angle that a line makes with a plane, we use the shadow of that line and work out the angle between the line and its shadow. Okay, I hope this helped.